Hello, my dear students, and welcome to today's class. As you can see on your screen, the topic is pressure. So, in this chapter, I'm going to tell you about pressure, different types of pressure, and applications of pressure. So, to start with, as you can see on your screen over here, right? You are aware about the strong wind in a cyclone that can lead to blowing of rooftops. This occurs due to difference in air pressure. Pressure is that virtue produced when a force acts on an object of mass x. In technical terms, pressure is defined as the force per unit area. So, pressure is force upon area. Force is measured in Newton, that is N, and area is measured as per meter square. Hence, pressure is Newton per meter square, which is also known as Pascal, written as PA. PA stands for Pascal. Okay. In SI system, the units of pressure is Newton per square meter. Okay. Fine, children, what is pressure? When any object is there, okay, and you are applying some sort of force to that, okay, that is called pressure. Fine. Now, okay, greater the force, greater will be the pressure produced and greater the surface area. Lesser will be, lesser will the pressure applied. Okay. Now, this I will explain you with a beautiful example. Okay. Here, the example is to show that smaller surfaces produces more pressure. Take a pencil. Okay. Take a pencil, like I have got a pen in my hand right now. What I will do, this is the pointed part. I will put it here. Okay. And press it. I'm applying pressure to it. Okay. Now, what will happen when I'm putting pressure on this way? What will happen? I will see pain. Okay. But if I take a pen or the pencil the other way where it is not pointed and I'm pressurizing on my finger, I will not feel much pain. I will not feel pain. Why? Because it is blunt from the side. But as if I speak about this way, when it's pointed, what will happen? Because the area is smaller, the pressure would be less. If the area is broader over here, so the pressure would be less. Okay. So now, what are the materials required in this activity? A pencil and a sharpener. Sharpen your pencil. Now hold the pencil in such a way that the pointed tip of the pencil is poking at one of your fingers. Apply a slight fork. Now hold the pencil on other way round such that the blunt end of the pencil is poking at the same finger. Apply slight force. You will see that when the pointed end causes more pain than the blunt end. This happens so because the pointed end has lesser area as compared to the blunt end. Hence, more pressure is there. Fine, children, just now I have explained you. Okay, now moving to the next one. I'll explain you this also. See, Raju applied the force of 10 Newton over a surface area of 5 meter per square. How much pressure is he applying? And I told you in the beginning, what is the formula for calculating pressure? Pressure is equal to force upon area. Force is 10 Newton and area is 5 meter per square. So pressure is equal to force upon area. We put force, that is 10, and area is 5. 10 upon 5, that comes to 2 Newton per meter square, or PA, that is Pascal. Okay, these are very simple equations. You can just solve them on your own. Okay. Now, moving to the next page. Okay. Fluid pressure. And what is fluid? Fluid is liquid. Okay. So, have you ever experienced fluid pressure? Take a plastic mug and dip in the bucket full of water with an open side facing downwards. What will you do? You fit in a bucket and put some and take a mug and put it upside down. Okay. The open side should be facing downwards. In other words, you are pushing the mug into the water. You are applying force vertically downwards. When you do so, you feel a certain force acting opposing the downward movement. This happens because the water in the bucket is pushing the mug upwards in the opposite direction. You can say that this pressure is exerted by the water. When you're putting it down, you will feel a sort of pressure which is pushing it up, and you're pressing it down. But you will feel that a certain force is acting, and that force is force of water. A similar thing can be experienced when you try to immerse a balloon in a bucket of water. The balloon will try to come up every time you try to push it. This is because of the pressure exerted by the water on the balloon. Okay. Now, the next one is atmospheric pressure. Okay. Do you know that we are surrounded by air every time? Yes, that is very true. Every time air is all around us, even right now I'm standing, or everywhere around me is air. Okay, the air around us also exerts a certain pressure. The weight of the air surrounding us on the atmospheric weight down on the earth, creating a pressure. This pressure exerted by the air above at any point is called atmospheric pressure. And how do we measure this pressure? Atmospheric pressure is measured using a barometer. Fine, children? Now moving to the next one. Okay. Atmospheric pressure varies with altitude. What is altitude? Altitude is height. Okay. So, the altitude is the height of a place from the sea level. The atmospheric pressure is indirectly proportional to altitude. This means that the atmospheric pressure decreases as we go to a higher place. When we climb a mountain, the air corner above us decreases, and hence its weight on it decreases, and thus decreases the air pressure. As we keep on moving up, what will happen? The atmospheric pressure, it will start decreasing. Okay. This means that the atmospheric pressure at the sea level is higher, and the atmospheric pressure at sea level is approximately 100,000 kilopascal. But we do not feel this atmospheric pressure because the blood pressure inside our body counteracts and balances the atmospheric pressure outside us. In our body, what is there? Blood is also there. Atmospheric pressure, it is working on us every time, but the blood in our body, what is it doing? The blood pressure inside the body counteracts and balances the atmospheric pressure. Fine. If the atmospheric pressure changes all of a sudden, then our blood pressure fluctuates rapidly, causing the blood vessels to burst. This happens at higher altitude. A speedy climb up the hill decreases the atmospheric pressure, causing a okay. Yeah. Causing a rupture in the blood vessels. So it is always advised to make the climb slow so that the body gets used to the change in the atmospheric pressure. Whenever we are climbing on the hill, it should not be like in a one. We should move slowly because the atmospheric pressure, every time it is increasing and decreasing, and our body is not adapt to it. So we should give some time to our body also to handle this atmospheric pressure, this change in atmospheric pressure. Fine. Now, atmospheric pressure varies with temperature. Yeah. Atmospheric pressure varies with temperature. Let us do an experiment to know how atmospheric pressure depends on temperature. First, fill the box half with cold tap water. Add some ice cubes in this box. Mark the bottles A as A and B. Place a balloon over the mouth of each bottle. Stand bottle A next to the shoe box and lay bottle B on the side of inside the box, as you can see here. Pour chilled water over bottle B for 2 to 3 minutes. observe both the balloons carefully. After some time, the balloon and water bee moves partially inside the mouth of the bee. Water bee. This happens because the chill water flowed on the surface of the water bee cools it, thus decreasing the temperature inside the bottle. So, decrease in temperature decreases the air pressure putting the balloon inside. Okay? Because the pressure of the balloon, okay, is decreased. So, what is happening? The balloon is getting inside it. Okay? Now, moving to the next one. Pressure exerted by liquids. Okay? You can see on your screens, I think. Okay. Now, take a plastic ball and immerse it in a bucket of water. The ball may not immerse because you feel there is a certain force pushing the ball upwards. Okay, the ball, you have taken the ball and you're trying to dip it in the bucket of water. But every time the ball is coming up, this upward force is force exerted by the liquid. The force will determine whether an object in water will get immersed or not, or in other words, whether the object will sink or float. Okay. Whenever we are putting any object in water, the water decides, okay, whether the object is going to sink or whether it is going to float. If the weight of the object being immersed is more than the pressure exerted by the liquid, then the object will sink at once. Okay. If the weight of the ball is more, it will sink. But if the weight of the object which you are going to put in water is less, what will happen? It will float. Okay. But if the weight of the object being immersed is less than the pressure exerted by the liquid, then the object will not sink but float on the surface of the water. Okay. Fine. Now, moving to the next one. Pressure varies with depth. Depth means how deep it is. Okay. Now, pressure increases as the depth increases. The pressure at the bottom of the sea is much higher than at the surface. That is why sea divers wear special diving suits to protect themselves. Similarly, dams are made broader at the base than at the top. This is because the pressure exerted at the bottom is more. Fine. Now, these are the different activities. You can just go through them, which share what is the aim to show that liquid pressure exerted is more as depth increases. Okay. And the second one is to show that pressure is the same and equal depth. This you can just go through them. Okay. There's nothing much to explain in this. Now, moving to the next one. They are all different activities. Okay. Application of pressure. Where are we going to apply this pressure? How is it useful to us? Okay. So, the first one is cutting with a knife. The sharp edge of the knife helps in cutting things more easily because the sharp edge has a small surface area, increasing the pressure applied. In case the knife is sharp, you will be able to cut the things more nicely, more easily. Okay. Why? Because the area where it's a pointed one, the area would be less and the pressure would be more. Okay. Broad school bag straps. Why? When you go to school, you may just see your school bags. They have a broader straps. Why? Because the school bag straps are made broader to increase the surface area. They are drawn to increase the surface area so that when the surface area increases, the pressure applied becomes less. Hence, school bags can be carried without much pain on the shoulders. So, children, whenever next time you buy a bag, make sure the bag straps, they are broader. Okay? That way you won't be finding it difficult to carry a bag on your shoulders. Fine. Now, drinking with a straw. Every child loves to have drinks with a straw. Okay. So, the atmospheric pressure helps us to pull the liquids upwards through the straw. Fine. Now, next one. Using the syringe. Okay, what is syringe? When you have to get an injection injected in your body, use a syringe. So, the atmospheric pressure helps us to draw blood from the veins with the help of a syringe. Okay. You have to inject medicine in your body. So with what are you going to do? You're going to use a syringe. Okay. And for that, the atmospheric pressure helps us to draw blood from the veins with the help of a syringe. The skies have broad surfaces. This is to reduce the pressure on the snow and to prevent the skies from sinking. Then we want to fix a nail in the wall or in the wood anyway. So the nail is pointed at one end and not on the other side. Nail कील देखिए. It is pointed at one end and the other end it is broad. The pointed end of the nail exerts more pressure. Hence, it can easily get fixed on the wall or board where force is applied. Okay. So, children, with this, I finished the chapter. I hope you all have understood. Go through it again. Read it as many times as you can so that the things get more clear and you're able to learn it without rote learning. Understanding is more important. Rote learning is not going to help you on. Okay. Thank you and have a nice day.